Hi, today we'll see the different working principles of different types of engines. Different types of engines, um, the basic mechanical engineering. The reciprocating engines, all IC engines are used for the automobile stationary applications or reciprocating type which contains the pistons connecting rod crankshaft arrangement convert to the rod of the motion piston to the rotary motion of the crankshaft. Petrol engine is used for running the petrol, gasoline, hydrocarbon made up of hydrocarbon and carbon compounds. Air petrol mixture is sucked in the cylinder during the suction stroke of the pistons. It is compressed during the compression stroke, ignited during the power stroke, and exhaust pushed out during the exhaust stroke. Spark plug is fitted on the top of the cylinder and spark to ignite the mixture. The latest cars and engines are employed with direct fuel systems instead of carburetor, and technical term used for MPFL stands for the multi-point fuel injection systems. Diesel engines are used for the diesel oil for its running. The diesel oil is light with low viscosity with high octane number in the diesel engine. Only the air is sucked into the cylinder during the suction stroke and compressed. The high pressure of the compression ratio being I is 22:1. The temperature also rises above the 100 degree, 1000 degree Fahrenheit. The diesel oil is injected by an injector at the end of the compression stroke which catches the fire burns due to the high temperature of the compressed air. No separate ignition system is used for the burn gases expand by pushing the pistons and piston down during the power stroke. Finally, the gases are pushed out during the exhaust stroke. Gas engine, compressed natural gas of the fossil fuel substitute the gasoline of the diesel and propane of the fuel. Although the combustion does the uses of the greenhouse gases, it is more environmentally clean the alternative to those fuels, and it is much safer than the other fuels. Even the spill of natural is lighter than the air and disperses quickly. The CNG is made for compressing the natural gas, mainly to less than the 1% containers at a normal pressure 200 to 20 bar and 2900 to 3200 psi. The cylindrical sheaves and the CNG is used for the traditional gas line of the internal combustion engine. Then the multi-fuel engines. These are the engines used for the combinations of two or more fuels. Usually the large C engines use a combination of the methane and diesel fuel. These are the attractive developing third world of the countries because the high cost of the diesel fuel. Most of the military vehicles are fitted with the type of the multi-fuel cable engine. Since the warfront engines, the vehicle should be run on any type of the fuel. Single cylinder engines. Single cylinder engines are used generally for the light vehicles like scooter, motorcycles, and minimum size of the single cylinder engine is 250 to 300 cc. Multi-cylinder engines. The automobile engines may have 1 or the 2, 3, 6, 8, 12, 16 cylinders. Single cylinder engine is used for the scooters, motorcycles, and 2 cylinders engines are used in tractor, 4 cylinder and 6 cylinder cars, jeeps, buses, trucks, Ashok Leyland, Comet truck and bus have a six-cylinder. The American passenger cars are the eight-cylinder engines. 12 and 6 cylinders engines also used for the some passenger cars, buses, trucks, and industrial installations of the three engines also used for the foreign and front drive automobiles. Inline engines. In this type of the cylinder arrangement, the four cylinders are arranged in a row or on line. The first and fourth cylinder are in phase, while the second and third cylinder are also phase, but in opposite directions. Firing order of the four cylinder is arranged in such a way that 180-degree revolutions of crankshaft power impulse on it. V-type engine cylinder. Two bank cylinders at an angle with each other along the single shaft, and the angle between the banks of the cylinders can be anywhere 15 degree, 120 degree, 60 degree, 90 degree being common. V engine have even numbers of cylinders 2 to 20 or more. V6 and V8s are the common automobile engines. V12s and V16s are found some luxury and high performance vehicles. Radial engine, the engine with the pistons positioned in a circular plane around the central crankshaft. The connecting rod of the pistons connected to the master rod, which in turn is connected to the crankshaft. A bank of the cylinder on the radial engines, always the odd number, ranging from the 3 to 13 more, and operating the 4-stroke cycle. Every other cylinder fires as the power stroke of the crank rotates, giving smooth operations. Many mediums and launches propeller driven the aircraft use radial engines. For the large aircraft, two or more banks of the cylinders are mounted together, one behind the other, the single crankshaft, making the powerful smooth engines. Opposed engine. In this type of the cylinder arrangement, the two cylinders are arranged horizontally opposite to each other. The piston and connecting rod movements are identical, which causes the engines and to perfectly balanced as records reciprocating forces, but because of two cylinders are not in line, the forces connecting the rods to produce the rocking couple. The crankshaft and the camshaft is positioned between the two cylinders. The engine having this type of the cylinder arrangement is running smoothly, much higher speeds. It is also gives the high outputs. Opposed piston engine. Two pistons in each cylinders with the combustion chambers in the center between the cylinder and pistons. A single combustion process causes two power strokes at the same time, with each piston is being pushed away from the center and deliver the power to the separate crankshaft at each end of the cylinder. An engine output is either on two rotating crankshafts on one crankshaft and interpreting the mechanical linkage. L-aide engine. L-aide arrangement of inlet and exhaust valves are located side by side and operated by the single camshaft. The combustion chamber and the cylinder is from an inverted aisle. All the valves are arranged in the line except the V8 L-shaped engines. The aide two lines in L8 engines or two valves or block ends, the cylinder is lid may be easily removed when required overhauling engines. Although the L-aide engine is rugged, is dependable, they are not particularly adopt the higher compressions. I-aide engine. I-aide is the overhead valve engine. The valves are located in the cylinder head in the engines or usually have the valves in a single row. V8 engines may be have the valves of the single row, double row of the in each banks. Regardless arrangement, a single camshaft actuates all the valves. F8 engine. The engine is a combination of L8 and I8 engines. The valves are usually inlet valve in the head and exhaust valve is in the cylinder box. Both sets are driven from the same shaft. T8 engine. The engine has the inlet and one or side of exhaust valves on the other side of the cylinder. The two camshafts are required to operate them. The air-cooled engines are the used in motorcycles, scooters, and Volkswagens and American automobiles. Engines also air-cooled and air-cooled engines. The cylinder barrels are usually separate and equipped with metal, give a large radiating and the surface of the increase the rate of cooling, and many air cooled engines are equipped with the metal and they shrouds the direct airflow around the cylinders and improved cooling. Since the engine are not use water, the problem of cold weather maintenance is eliminated. Almost all the two-wheeler engines are air-cooled type. Some of the military tanks are not employed for the cooling the engines. Water and liquid engines. Water-cooled engines are used in buses, trucks, cars, four-wheelers, heavy-duty motor vehicles. These engines are antifreeze and compound as the serve cooling medium chambers and valve seats and valve seats and valve items of after passing the engines when it is cooled drawn through the radiator. Engine with petroleum systems. In these systems, the lubricant is premixed with petrol at the timing of filling. This is being practiced on the mopeds in small two-wheelers. The engines of the splash lubrication systems. In these systems, big end of the connecting rod is having the scoop. This will be take the lubrications of the oil present in the sump of the engines and splash it to the cylinder valve to the other components. This is implemented in all stationary diesel gensets. Engine with pressure lubrication. In this type there is a separate pump relevant circuit for supply the lubrications of the oil to all moving parts of the engines. This type of is supplied in multi-cylinder heavy-duty engines. Naturally aspirated engines. In this type is sucked the cylinder downward movement and the pistons of the top dead center to the bottom dead center. Supercharged engine. In this type, airtake of the pressure is increased by using the blower driven by the engine crankshaft. Turbocharged engines. In this type of intake pressure is increased to use the turbine blower driven by the engine exhaust gas pressure. Rotary engine, the flux Winkle introduced the rotary engines. It works the Otto cycles, reciprocating the part of the pistons. It makes the use of the rotor instead of pistons, which turns inside the chamber. Designs gives new challenges exiting the reciprocating engines. Different components of IC engine: cylinder block, cylinder head and crankcase, piston rings, piston ring, gudgeon pin, connecting rod, crankshaft and flywheels, valves over the valve mechanisms, rocker arm and camshaft. Cylinder block comprises the cylinder head and crankcase. These three parts form the foundation and main stationary body of the automobile engine. This serves as a support to enclosure the moving parts in modern engines. The cylinder block and crankcase from the single casting, which gives the rigid structures. Ribs are cast in the crankcase to give the extra strength and to support the main. In some cases, the camshaft bearing the cylinder block may also have the separate crankshaft. For the crankshaft, which is mainly confined to large engines and marine and stationary engines, separate aluminum crankcase would result in savings in weight as well as enable cheaper and quicker replacement. Block consists of three parts: the cylinders and pistons slide up and down. The ports are opening for valves, the passages for the flow of cooling water. Cylinder head. The top of the cylinder is converted by the separate cast piece known as the cylinder head. The cylinder head is bolted to the top of the cylinder block. It contains the combustion chamber, spark plug and injector valves. It has the passengers flow the cooling water. Crankcase is attached to the bottom face of the cylinder block. It acts as the base of the engine, which supports the crankshaft, camshaft, suitable bearings, and provides the arms for supporting the engines on the frame. The oil pan and lower part of the cylinder block together is called the crankcase. The piston is considered to be one of the most important part in the reciprocating engines, in which it helps to convert the chemical energy obtained by the combustion of fuel into the useful mechanical power. The purpose of the piston is to provide by means of conveying the expansion of gases to the crankshaft beyond the connecting rod without loss of the gas from the above oil from below. The piston is essentially a cylindrical plug that moves up and down of the cylinder. It is equipped with the piston rings to provide the good seal of the cylinder wall and the pistons. Piston rings. The piston rings are fitted in the grooves of the pistons to maintain the good seal between the piston and the cylinder wall. There are the three functions of the piston rings as follows: to provide the pressure seal, prevent the blow by burnt gases. Blow by the name describes the escape the burnt gases from the combustion chamber. To form main path for conduction of heat from the piston crown to the cylinder walls. The control flow lubrication oil into the cylinder and preventing the lubrication oil reaching the combustion chamber. with constant beast and carbonization. The piston pin and gudgeon pin. Piston pin or gudgeon pin contacts connect the pistons and small end of the connecting rod. Connecting rod. The connecting rod is the piston connecting between the piston and the crankshaft. It joins the piston pin and with the crank pin. The small end of the connecting rod is connected to the piston pin and big end is connected to the crank pin. The function of connecting rod is convert the linear motion of the pistons into the rotary motion of the crankshaft. First part in the power transmission systems on to which the reciprocating motion of the pistons is converted into rotary motion of with the help of the connecting rod. The connecting rod consists of the crank pins, bibs and balancing weight and the main journals. Big end of the connecting rod is connected to the crank pin of the crankshaft. Center to center, the distance between the crank pin and crankshaft is half of the piston displacement. During this stroke, thus one complete revolution of the crankshaft makes two strokes of the piston's flywheel. The flywheel is fairly heavy steel attached to the rear end of the crankshaft. The size of the flywheel depends upon the number of the cylinder and general construction of engine. The flow power from the engine cylinder is not smooth, although the power impulse the multi-cylinder engine the overlap or follow each other fairly even flow power. However, the additional leveling of the power impulse in record. This is done by the flywheels. Valves. Valve is a device to close and open passage in the motor vehicle engines. Two valves are used for each cylinders. The valves and exhaust valves are the fuel is admitted to the cylinder by the inlet valve and burned. The gases escape the exhaust valve. When closed, the valve must seal the combustion space tightly. The valves used for the modern passenger cars engines and terms of the puppet mushrooms valves. Rocker arm. The function of rocker arm reverse upward portions and the push to then downward portions. Camshaft is simply the shaft on which the cams are mounted. The camshaft is mounted the bearing in the lower part of the cylinder block is the most inline engines. A cam is a device that changes the rotary motions of the camshaft into the linear motion of the follower or lifter. Camshaft is responsible for opening a valve. A camshaft has a number of cams along a length. Two cams for each cylinders, one to operate the inlet valve and other to the exhaust valve. In addition, the camshaft is eccentric operate the fuel feed pump and gear drive, ignition and distributor and oil pump. Basic engine terminologies. A number of the basic terms used to describe and compare the engines. A few commonly used terms. Top dead center. This refers the position of the crankshaft when the piston is in its topmost position, the position of the closest cylinder head. Bottom dead center. This refers the position of the crankshaft when the piston is in the lowest position, the position of farthest from the cylinder head. The diameter of the engine referred as a bore. The stroke of top dead center to the bottom dead center is called the stroke, denoted by I. clearance volume, the volume of the cylinder above the piston's top dead center. Piston displacement, the volume of the swept piston moving from top dead center to the bottom dead center is also called the swept volume. If V is the cylinder bore, S is the stroke, V is equal to pi by 4 d square S, the engine capacity, the total piston's displacement, and or swept volume of all cylinder. If n is the number of the cylinder, V is the piston displacement and engine capacity of Vd and Vs, the compression ratios. This indicates the extent of charge in engine compressor. This is calculated the ratios of the volume above the pistons and PDC to the volume of TDC. Mean effective pressure. This is the average effective pressure throughout the whole power stroke. In fact, the cylinder pressure varies considerably. The power stroke that is most refer mean pressure instead of this express the kilopascal bars. The power it is the work done period of time during the same amount of leisure would be required the more power indicated per horsepower. The horsepower is developed within the engine cylinder is called indicated horsepower. This is calculated the area of the engine's brake horsepower. This is the actual delivered. The crankshaft is obtained dedicating the various power losses of the engine from the indicated power. It is measured the dynamometer and express the kilowatts, and it is always the indicated the power working of 4-stroke engines. First stroke, intake stroke or induction stroke. The piston travels from top dead center to the bottom dead center with intake valve open and exhaust valve closed. This creates an increasing the volume of combustion chamber, which in turn creates the vacuum of the resulting pressure differential through the intake systems from the atmospheric pressure on the outside of the vacuum on the inside causes the air pushed into the cylinder. As the air passes through the intake, the fuel is added in the desired amount by means of the fuel injector carburetor. Second stroke, compression stroke. When the piston reaches to the BDC, the intake valve closes, the piston travels to the TDC. With all valves are closed, the compressed air of the fuel mixture raising the both pressure and temperature of the cylinder. The finite time required to close intake valve by means that the actual compression doesn't start until some times after the BDC. Near the end of the compression stroke, the spark plug is fired and the combustion is initiated. The combustion of air-fuel mixture occurs in very short but the infinite length of the time with the piston near the TDC. It starts near the end of the compression stroke, slightly before the TDC loads into the power stroke, and slightly after TDC. The combustion charge changes in the composition of gas mixture to that exhaust products and increase the temperatures in cylinder to a very peak value. This in turn raises the pressure in the cylinder to a very high peak value. The third stroke, the expansion stroke or power stroke, with all valves are closed, the high pressure is created by the combustion process and pushes to the pistons away from the TDC. This is the stroke which produces the work output and engine cycle On the pistons travels from TDC to BDC cylinder. Then the lead in the power screw, the exhaust screw, and exhaust below the down occurs. The pressure and temperature of the cylinder are still high relative to the surroundings at this point. The pressure differential is created through the exhaust systems, which is open to the atmospheric pressure. The pressure differential passes much on to the exhaust gases pushed out of the cylinder through the exhaust systems. When the piston is nearer to the BDC, the exhaust gas carries away the high amount of enthalpy. The BDC reduces the work obtained during the power strokes, but is required because of the finite time needed for exhaust blowdown, forced stroke, exhaust stroke. By the time of the pistons reaches to the BDC, the exhaust blowdown is complete, but the cylinder is still full of exhaust gases at approximately atmospheric pressure. With the exhaust valve remains open, the piston now travels to the BDC to TDC in the exhaust stroke. This pushes the most of the remaining exhaust gases out of the cylinder into the exhaust systems and about the pressures, leaving only that happened in adherence of the volume when the piston reaches to the TDC near at the end exhaust stroke by the TDC. The intake valve starts open so that it is fully open TDC when the new intake strokes starts the next cycle. Near TDC, the exhaust valve starts to close and finally it is fully closed. Sometimes at TDC, the period of exhaust valve start to close, finally fully closed of the TDC. This period when both intake valves and exhaust valves are open is called closed valve overlap. The theoretical valve of timing diagram is that the operations of four-stroke, the Otto cycle engine, the inlet valves open during the suction stroke, the exhaust valve open during the exhaust stroke. The exact moment at which each of the valves opens and closes with reference to the position of the pistons and crank can be shown graphical. The diagram is known as the valve timing diagram. Theoretically, the inlet valve open exactly at the beginning of suction stroke, closes at the end of the stroke. Both the valves are remain closed during the compression and power stroke. The exhaust valves open exactly at the beginning of exhaust stroke and closes at the end of the stroke. The theoretical valve timing diagram of the four stroke Otto cycles. By the actual practice, the above cycle is slightly modified. The exact moment of opening and closing the valves with reference to the pistons and the crankshafts. The working of four-stroke engines, the engine having the heavy motor and stationary power plants, big industrial units and ships mostly operates of diesel cycle. The volume cycle of diesel cycle refers from the Otto cycles in one respect. The heat is added at the constant pressure Instead of constant volume, this compresses the two adiabatic process in one constant pressure, heat addition the process in and one constant volume and heat rejection process. The diesel engines mostly used for the heavy oils. Diesel oil is the most common. The diesel engines is only used as the compressed air in the cylinder to the high pressure. The temperature this compressed air becomes sufficiently high to ignite the fuel. Diesel is injected to the cylinder, the compression stroke, which itself ignites the high temperature of the compressed air. There is no spark plug in the diesel engine. The four-stroke diesel cycle, the compression, ignition, and the four-stroke engine stroke as follows. The suction strokes. During the suction stroke, the pistons moves down from the top dead center to the bottom dead center. Air is sucked into the cylinder through the open inlet and with closes at the end of the stroke. The exhaust valve remain closed during this stroke. The compression stroke. The compression stroke is moves outward upward from the bottom dead center of the position. The inlet valve and exhaust valves remains closed. The air is compressed in the cylinder with upward movement of the pistons. At the compression ratio, the engine is 10 to 20 and degree is 100 degrees centigrade. The working of power stroke. At the end of the compression stroke of the fuel injected to the hot compressed air which starts burning, maintaining the pressure constant. At the point then the fuel supply is cut off. Theoretically, the fuel is injected at the end of the compression stroke. The injection is continued till the point is cut off. Meanwhile, the piston moves from the point 3 to 4 and this stroke is called the constant pressure stroke. Theoretically, the power stroke starts from the point 4. The hot gases now expand adiabatically to the point in the cylinders and pushing the pistons down. Piston is finally reaches the bottom dead center. The exhaust stroke. The piston moves upward. The inlet valves remains closed and the exhaust valves open. The greater part of the burnt gases because of their own expansion. The upward movement of the piston pushes remain the gases out through the open exhaust valve. Then the cycle is completed. The two-stroke cycle engines in the four-stroke cycle engines, there is the one of the working shaft is the two revolution of the crankshaft in the cycles of four-stroke of pistons, whereas in the two-stroke cycle engine there is the one working stroke for the every revolution of the crankshaft. The 1838 Barrett Englishman is described the mechanisms of supplying the charge of the to the cylinder by means of separate pumps. 1878. A lot of contributions in this direction is described by the two-stroke cycle and closed cycle. Two-stroke cycle engines are widely used for the small powers required in auto cycles and scooters and motorcycles. In two-stroke cycle engine, the suction exhaust strokes are eliminated. There are only two remaining strokes in the compression strokes and the power stroke, and these are usually called the upward stroke and downward stroke. respectively, and the uh, and these are usually called the upward stroke and downward stroke respectively. Also, instead of balls, there are inlet and exhaust port of the two-stroke cycles engines. The burnt gases of the exhaust port of the first charge of the which enters the cylinder nearly at the end of the working strokes through the inlet port. The working of two-stroke SI engine upward stroke. During the upward stroke, the piston moves upward from the bottom dead center to the top dead center, compressing the charged air petrol mixture in the combustion chamber of the cylinder. Due to the upward movement of the piston, the partial vacuum is created in the crankcase and new charge is drawn into the crankcase through the uncovered inlet port. The exhaust port and transfer port are covered when the piston is at the dead center positions. The compressed charge is ignited. The combustion chamber by spark is given by the spark plug downward stroke. As soon as the charge is ignited, the hot gases compress the pistons and moves downward, the rotating the crankshaft, thus doing the usual work. During this stroke, the inlet port is covered by the pistons and new charge is compressed in the crankcase. Further, the downward movement of the pistons uncover the first the exhaust port, then the transfer port, and ends the exhaust starts through the exhaust port. As soon as the transfer ports open, the charge through the is pushed into the cylinder. The charge strikes the deflector on the piston crown, rises the top of the cylinder, and pushes the exhaust gases. The piston is now the bottom dead center of the piston. The cylinder completely filled with fresh charge, although it is somewhat diluted with exhaust gases. The cycle even repeated, the piston making the two-stroke for each revolution of the crankshaft. Working of two-stroke diesel engine. The two-stroke diesel engine is similar to the SI engine except two changes in that no fuel is added to the incoming air. The compression is done on air only. Instead of spark plug, the fuel injector is located in the cylinder near the compression stroke into the hot compressed and combustion is initiated by the self ignitions. The two-stroke cycle engines are one working stroke for each revolution of the crankshaft. Four cycle engines gives a one working stroke of two revolutions of the crankshaft. Hence, theoretically, the power developed by the two-stroke cycle engine is twice developed by the four-stroke cycle engines. For the same engine, the speed and the cylinder volume turning moment on the crankshaft is more even. Two-stroke engine due to the one working stroke for each revolution of the crankshaft, and so lighter wheel is required. For the same power, two-cycle engine is more compact and light and requires less space than the four-cycle engine. Therefore, it is more suited for the motorcycles and motorcycles and scooters. The two-stroke cycle engine is similar in construction mechanisms, and these are no valve and valve mechanisms in it. The ports are easy to design. They are covered and uncovered by the movement of the pistons itself. It has a mechanical efficiency, absence of camshaft, rockers, etc. It gives the less torsional oscillations. Uh, it requires the fewer parts due to its simple designs. It can be easily reversed if it is of the valve and less type. This is there is a sieving in work required to overcome the frictions, inlet and exhaust code demerits in two-stroke cycle auto engine. The fuel consumption is high because the fresh charge is likely to be stored the escaping through the exhaust port. The actual compression starts when the ports are completely closed by the upward movement of the pistons after the few degree of revolution of crankshaft is the actual compression ratio and hence the thermal efficiency of the two-stroke cycle engines. Then the charge is diluted, the burnt gases due to complete scavenging. It is greater noise. It comes the more lubricating oil. There is the greater wear and tear of moving parts. Petrol engine. It is working on Otto cycle, constant volume cycle. It is used as the spark plug initial combustion. During the suction air fuel mixture is admitted. It requires the carburetor to mix the air and the fuel. The compression ratio is 8 to 10. The engine speed range is 1500 to 7000 rpm. The start engine is easier. The weight of the engine is less. It requires less maintenance. Fuel consumption is more. These engines are used to wheels and cars. The engine vibration is less. Thermal efficiency is less. The torque capacity is less. The engine acceleration is more. It is the diesel cycle, constant pressure cycle, the auto ignition type, fuel injector. During the suction only, the air is admitted. The it requires the fuel injection pump to inject the fuel. The compression ratio is 15 to 25. The engine speed is 800 to 3000 rpm. Starting engine is harder. The weight of the engine is more. It requires the more maintenance. Fuel consumption is less. These engines are used for the cars, heavy-duty vehicles, and thermal efficiency is more. Torque capacity is more. The engine acceleration is less. One working stroke for every two revolutions of the crankshaft. Heavy flywheels is required and engine runs unbalanced. Engine is heavy. Engine design is complicated, more cost and less mechanical efficiency due to the more frictions on many parts, more output due to the full fresh charge intake and full burn gases. One working stroke for each revolution of the crankshaft. Light flywheel is required and engine runs balanced. Engine is light. Engine design is simple, less cost, more mechanical efficiency, and less output of mixing fresh charges and burn gases. The engine does not heat up. Engine is water cooled, less fuel consumption and the burning of fuel. Engine requires the more space, complicated lubricating systems. Engine creates the less noise used in cars and buses, trucks. Engine consists of inlet and exhaust molds, more thermal efficiency. It consumes the less lubricating oil. less wear and tear of moving parts, weight of the engine per horsepower is less, pollution is less, the engine heats up, engine is air cooled, more fuel consumption and fresh charge if mixed with exhaust gases. Engine requires the less space and simple lubricating systems. Engine creates the more noise and used mobile scooters and motorcycles. Engine consists of inlet exhaust ports, less thermal efficiency. It consumes more lubricating oil and the, the greater wear and tear of moving parts. The weight of the engine horsepower is more, pollution is more. Fuel supply systems in engine. The fuel supply systems of petrol engine and diesel engine will vary. In petrol engines, the petrol fuel should be mixed with air vaporized form. The air and fuel mixes will be ignited by the spark plug, whereas the diesel is sprayed at the end of the compression stroke. The fine automated form of the ignition is initiated automatically because the pressure, temperature on the compression strokes. The fuel supply petrol engines, the process of breaking up the fuel in it and the particles is mixing with air and the contributions as the internal combustion engines and have a very low compression ratio use highly volatile liquid of the fuel such as petrol and paraffin etc. The carburetor is the process must be recurred to the carburetor. The fuel is completely broken into the minute of vaporized particles. Then the vaporized mixed with air in the proper ratio. The homogeneous mixture of fuel and air, this applied is supplied to the engine cylinder during the suction stroke of the engine. Single and simple jet carburetor. The simple carburetor can be seen. The carburetor consists of basically float chamber and metering of mixing chamber. Here the carburetor throat is a large opening and causes the carburetor body. Air flows through the throat and which is the venturi. As the air flows the venturi through, its velocity increases, the pressure decreases, the fuel spread into its air mass of the carburetor fuel jet. The float chamber is the storage of space for fuel before being drawn into the horn. The float assembly controls the entry of the float chamber of the fuel tank. The float assembly consists of hollow float hinge, the needle valve and needle seat. The float rides up and down on the top of the fuel. It operates the needle valve. The upward downward movement of the needle valve closes and opens the fuel passages. The float chamber is respectively. The float device is constantly maintain the level of the fuel or in the level of the jet constant. The opening is provided in the float chamber. In the hole is usually vented to the atmosphere. The prevent the pressure on the vacuum from the building up in the bowl. The main discharge of the tube or opening connects the bottom of the float chamber with the center of the air on. The small brass fittings with carefully sized hole or orifice and fitted over the end of the main, and the small brass fittings with carefully sized holes and the different venturi arrangements or and the fluid pushing of the air on is venturi. The different venturi arrangement and fluid flow directions is can be seen. The venturi create the vacuum as the flowing is speeded up. The stretched swiveled restriction, the fuel is freed in the stream of the flow through the venturi. Most of the motorcycles, passengers or carburetors are downdraft and throttle valve around the disc mounted shaft. It is located between the venturi and the engines, the inlet of the induction systems. The valve can be tilted to various linkages, the carburetor panel, pedal driver's cabin, the depressing the actuators of the pedal opens the throttle valve and permits an increasing amount of the fuel and mixture reaches the engine intakes and manifold. This will be increase the power input and output of the engines hence the vehicle speed. The suction stroke of the engine is reduces the pressure of the cylinder. This causes the pressure of gradient inlet systems. The pressure drop causes airflow through the inlet systems. At the throat of the venturi meter on air of the throat is called the carburetor depressions. And now the pressure in the fuel injector. The venturi is less than the pressure in the float chamber. Remember the float bowl is vented to the atmosphere and the pressure difference is created that causes the fuel to be ejected out through the fuel jet and the quantity of the airflow through the venturi meter can be increased by decreased by increasing or decreasing the extent of opening the throttle valve. When the air quantity is increased, the carburetor depressions also increases in terms of increases the fuel flow from the fuel jet. It gives the constant air fuel mixtures at only one engine speed and load, but the practically the engine has different speeds and feeds and the high speeds is the carburetor gives the rich mixtures at low speeds and supplies the weak mixtures to the engines. Here the suitable for only engines running at constant speeds and at constant load. A low speed or weak mixture are supplied by the carburetor will not be ignited properly. When the throttle valve is opened suddenly, it gives a weak mixture. This is because of the fuel flow prevented inertia effect. When the throttle valve is opened suddenly, the working of the simple carburetor is influenced the change of the atmospheric pressure. A simple carburetor gives a rich mixture of high altitudes due to the less density of air. The working of simple carburetor is affected by the changes in atmospheric pressure. If this carburetor is set one season to give the proper air fuel mixture, it will not work the other seasons. If setting is done in the winter season, it gives a rich mixture of the summer seasons. The fuel injection pump consists of the cylindrical barrel having the two ports called the supply port and the spill port. The plunger reciprocates inside the barrel. The reciprocating motion of the plunger is obtained either by the cam. The plunger has a vertical slot, helical grooves cut in outer surface. The position of the plunger is controlled the crack of the shaft by the governor as per the position of the helical groove and cut the quantity of the fuel delivery in increased or decreased. When the cam is not action of the plunger bottom of its strokes, the plunger reciprocated by the cam movement of the fuel injection pump. The supply port, spill port are uncovered. The diesel from the feed pump after the filtration is forced into the barrel. When cam pushes the plunger, it moves up. The supply, the spill points are closed. The plunger moves upward and downward. The fuel above the plunger is compressed at high pressure is developed. Due to the high pressure, delivery valve is pitted against the spring force. The fuel flows through the passage to the atomizers. When the plunger is further moves, the helical groove connects the spill out port and the portions of this plunger. Thus, the sudden pressure drop and the remaining fuel is returned through the spill port is brought back to the seat by spring force. This cycle is repeated that the fuel flows to the atomizer. The quantity of the fuel is delivered to control by rack and pinion arrangement. When the rack shaft is moved, the pinion is rotated. This alternate quantity of the fuel delivered from the delivery valve and the amount of the supply is varied. The function of fuel injectors in the diesel engines speed the diesel fuel finally atomized form penetrate to mix well the air, which is the high pressure and temperatures. These then prevailing the pressure and temperatures will help or and initiate the combustion process automatically. Because of this feature, this engine is called auto ignition engine. Okay, we will see in next video.